Hello everybody, my name is João Ferreira. I am one of the organisers of this workshop and I will be presenting a starter topic for the beginning of these proceedings. I will be talking about forestry robotics, and the question that I will be posing to you is this the right bet at the right time? I am with the Institute of Systems and Robotics from the University of Coimbra, Portugal, and also a senior lecturer at Nottingham Trent University, or NTU, in the UK. So, what is forestry in fact? We can call it the practice of creating, managing, using, conserving and repairing forests, woodlands and associated resources. But what is this more specifically? So, first of all, the core industry in forestry is called silviculture. It concerns the growing and cultivation of trees to provide timber and fuel wood as primary products, and also many secondary commodities. And this would include wildlife habitats, recreation and tourism, water quality, and landscape and community protection. Now, forestry also implies many subsidiary industries with high added value, and these include apiculture, forest farming, that would include the growth of non-timber forest products, or NTFP, and this would comprise decorative ferns, specialty mushrooms, strawberry trees, and many other products. So as you can see, it's not only the primary industry here, you also have many other satellite industries around this practice. So this means that forestry has indeed a substantial weight in world economy. It creates many jobs and wealth, so this is recognized across the world as something that makes forestry a very important practice. Forestry also plays a crucial role in carbon sequestration. This means that forestry is part of what is called the carbon cycle, so it removes from the air the polluting carbon that is transferred into the atmosphere by many polluting industries. So you can see where forestry is really important for humankind. However, for all of its potential, traditional forestry, so forestry in the traditional sense, is still a risky investment with very slow returns. And this is because wood is a natural resource in the wild, which takes a long period of time to renew itself. And this period ranges from 12 to even over 100 years in some cases. So this is actually too long in terms of modern economy's investment cycles. As a result, most companies and private owners actually convert forests in their natural form into grazing lands, or industrial plantations involving single tree species that yield a higher rate of return on invested capital. Now, this could be, for example, Acacia magnum, oil palm, pine tree, or even eucalyptus. And in fact, in countries with lower GDPs per capita, this is the only realistic option left for private owners. As a consequence, unfortunately, forestry is many times seen more as a strategic commitment for the future by governments instead of an investment in the present. Now, this leads to an increasing lack of manpower due to low salaries, and you have to take into account the harshness of forestry operations and how hazardous these might be, and also the progressive abandonment of rural areas and of practices such as pastoralism. Another thing that comes into play in terms of forestry is that we are seeing an increasing amount of wildfires around the world. Specifically in Europe, the European Commission says or reports that Europe is affected by about 65,000 forest fires per year. More than 85% of this burnt area in Europe is in the Mediterranean countries. And over the past 25 years, this has been reflected in numbers such as in Greece, having 1,500 fires per year on average, Italy having 9,000 fires per year, Spain 15,000 fires per year, and Portugal, the worst offender of this group, 18,000 fires per year. As a matter of fact, in 2017, Portugal was one of the most devastated regions worldwide. There were 500,000 hectares, so this is nearly 1.5 million acres of burnt area, over 100 fatal casualties, and this has meant a great deal in terms of the forestry practice in Portugal and all of these countries. Because wildfires lead to the lack of forest regeneration capacity and therefore to a negative effect on the environment which is impossible to measure. And this all leads to a vicious circle of rural abandonment. So, what is the way forward, I ask? And in the context of this workshop in particular, I would argue that it would be something in the lines of what we could call Forestry 4.0. This would include automation and the Internet of Things for forestry, and also autonomous systems, which is the focus of the workshop. Automation has slowly but steadily been introduced for decades now. The Internet of Things for forestry in particular is a relatively recent trend, very similar to the Internet of Things for agriculture, but with particular focus on environmental control and early warning on wildfires. Autonomous systems, robotics, however, have been much more challenging, even though we, as I said, have some decades already in advance of work on this, because the environment is much more unstructured than in agriculture. So even when forests are actually a result of plantation, tree lines are the only structured entity, the rest being completely haphazardous in terms of placing. Natural obstacles are generally left in place. Wildlife is not only an unpredictable obstacle, it has to be protected. So all of this should be taken into account. Also, we have rough terrain traversability, for example, steep slopes. To do actually autonomous systems, you have to have reasoning and planning under a high level of uncertainty, which is something that is still very much a work in progress. But most importantly, forestry imposes extremely challenging conditions for perception. So, talking specifically about challenges of sensing for forestry robotics, you have dense homogeneity of the environment because you have all this dense vegetation with trees and other types of plants all around. You have issues such as lens flare and overexposure due to the sun coming through the canopies of trees. You have issues such as fog and rain, and also wind, which makes for a lot of motion in all the surroundings, and that, for example, kind of beats any type of motion detection system, for example. So everything is in motion, in fact, in those cases. However, it's not only a question of challenges to sensing, it's also a question of challenges in terms of algorithms. So, for example, there are still many robustness gaps in core techniques such as holistic parsing for forest scene analysis, where no generalizable solution has yet been found for segmentation classification of, for example, the object of the forestry task or any distractors or secondary or ancillary entities to the task. Also, another issue is visual odometry and SLAM in forest environments, which is particularly difficult due to the difficulty in, for example, tracking down landmarks. And finally, if swarm robotics or teams of robots seems to be a good idea to be used in a forestry application, there is still the challenge of cooperative perception, which is the research on this matter is still very in its infancy. The overall consequence is that robotics for forestry is still extremely challenging. That means both that it is an exciting new field, which is great because that means that we can come to this workshop and show our latest results on our work in the field. But it is also outside the comfort zone in robotics. So there are very few research groups working in the area. Now, I'd like to turn your attention specifically to two projects that I'm contributing for. One is safety, exploration and maintenance of forests with the integration of ecological robotics, in short, the SameFire project, and also the CORE project, Center of Operations for Rethinking Engineering. SameFire has the main aim of attaining forest landscape maintenance for fire prevention using a robotic team composed of a ranger and several scouts. And Michael Colseiro later on will be talking in more detail about this subject, but I would like to give you a small introduction to the project so that you may understand some of the points that I'm trying to make concerning the main question that I asked at the beginning of the presentation. So the aim, as I explained, is to promote fire prevention using a robotic team to cut down and mulch flammable material, mainly live material, and that would include brushwood, bushes and shrubbery, or herbaceous plants, or small arboreal vegetation, and also in some cases flammable debris, although as I said we will be mainly focusing on live material. So, taking into consideration projects such as Samefire or any other project relating to forestry robotics, what do you think? Is this the right bet at the right time, as I asked in the beginning? I really hope that this workshop will help answering this question through lively discussions on what I hope will be exciting presentations of ongoing work in the area, because I feel that this is really a tipping point in terms of forestry robotics. In fact, I would go as far as to say that we want you not only to help us answering the question, as I said, but also to join us in this adventure, which I think will be really enthralling and will bring a lot of new things, good things, to robotics in general. Thank you very much, and I hope you enjoy the rest of the workshop.